Hello, I'm Adam. I am a web developer over at Simpler, and this talk is about Bulletproof Push, which is a very brave title given that the reason I actually wrote this is because we fucked up. I'll be honest. We fucked up, and I decided to do a bit of work researching into some push stuff, and I found some really interesting stuff out of it. This talk is quite heavy, focused on the iOS side, because that's where all the problems are. But it should encompass kind of both a little bit. So the first thing, there we go. First thing is, what is push? I'm sure you all know I'm speaking to Self as mobile. It's these little notifications that come up on your screen and annoy you, and the little badges that you get, and also you can use it within applications to receive kind of updates whilst you're in the applications. And let's talk a little bit about why they work. So when you're in an application, you can have a persistent connection to that application server. So in the case of Twitter, you can stream things. So this is a stream from the BAFTAs hashtag the other day. And you can stream this data really easily and reliably. But in the background, you've got a problem. You can't have all these simultaneous connections up to the cloud, up to those those app servers, because it's going to very quickly give you a bad experience. Your battery life just isn't going to last. So the whole point of push notifications is it allows you to have one persistent IP connection over to APNs, to Apple's push notification service, or to GCM, Google Cloud Messaging. So one connection to the cloud, and then obviously your battery's going to be fine. So how does it exactly work? Well, first we launch our application, and we ask the user, would you like to allow push notifications? And they accept this, and from that we'll get a token back. The token we're going to send up to our web server, our application server, and when we want to send a message to the device, we create a payload. So in this payload, we've got our message, a badge to let them know that they have one push it real good, and if you want, the custom sound as well. And that gets sent down to the APN or the GCM service, which will then kind of handle sending it over to the phone for us. And we get our message up here. Now, a lot of people delegate this off to another push service. I don't really like this. I'm not a big fan of this. This was part of our problems. There are a few companies that do this. One Signal, Urban Airship, these guys. That joke seemed so much funnier before I read the tech news this morning and realised that sadly a local company has closed down also. But one of these, One Signal, is free, 100% free, unlimited devices. And I don't know about you, but this makes me worry a bit. So the thing that makes me worry more than that, more than relying on these services, is having your data in multiple places. So here on the left, we've got our application server. It's got all your user IDs, their details, their names, emails, whatever you've got in there. And on the right, you've got maybe paths as database. We've got reference back to that data. And this causes a few problems. First of all, we've got multiple points of failure. These services can and do go down. In fact, they might go down permanently. Will they still be running in 6 months? We don't know. Synchronization issues. Have you considered your workers? What if your workers go down? What if you have race conditions in your application? Will you end up with the right IDs in both places correctly? And this is particularly prevalent when you've got multiple environments. So fairly manageable when you've got your traditional production, stage, and edge environments. But a lot of people are kind of moving away to feature-based environments where every single branch spins up in its own service, in its own kind of staging. How do you manage that? Do these products provide those services? None of those three do. So my preference is smash them together, keep all this in your application server. And there's a few tools that will help you do this. It's not that much work to do push yourself. For Ruby, you've got GCM and Houston. Node, you've got Node GCM, Node APN, and for Java, Java APNs, and Google's GCM. Clearly, you can tell that Houston's the best because it's the only one with the logo. So let's talk about some other gotchas, and these are all iOS-based gotchas. Push tokens can be invalidated at any point. Bold comment, but in reality they kind of can, because when you reinstall the application, your token might change, depending on how much time has passed. When you update iOS, your token might change. When you restore your phone, your token might change. There are lots of different things that can happen that can make your push token change, and you can't rely on it. The second thing is that the Apple feedback service, the thing that actually tells you this token is no longer valid, has a major flaw. So this is a point of failure that you can't rely on. And to take a quote from the Apple website, if you remove the app from your device or computer, then send a push notification to it, you'd expect that device token to be to have that device token rejected and invalidate the device, and it should appear in the feedback service. Seems perfectly reasonable. You read the next sentence. However, if it was the last push-enabled app on your device, you've lost the consistent connection to the feedback service, and it's just not going to show that. So using this as a point of knowing whether tokens are valid or not is just not reliable. Not reliable at all. So the way that we've kind of dealt with this is making our push notification systems dumb. Making it dumb and delegating to the app and the operating system, really, of the phone, as to whether it should receive a notification or not. Now, when you actually register for push notifications, there are two method calls on iOS. Register for remote notifications, and there's also register user notification settings. These do two very different things. The register for remote notifications asks the system to give you a token, and it will kick back a token when it's ready. And register user notification settings brings up that little window, asks you user permission whether they'd like to see it or not. But a lot of frameworks will wrap these two method calls up together into one call. For example, Ionix's push library will do this. They'll wrap it up into one, but they behave very differently from one another. And a problem happens here. So this is a flow that I put together from some testing. There's a lot going on here. So we'll focus on the first few steps at least. So we install our app, we'll launch it for the first time. We'll call register for remote notifications, and we'll call register user notification settings. So the user at this point has a pop-up on their device, and they say, yes, I'll allow notifications. And we get the callback, we get that token. We then uninstall the application, reinstall it, launch it, call register for remote notifications. Something weird happens that didn't happen last time. You get the token back straight away. So if you're using that callback as a point of truth that you've got a valid token, you're wrong, because we've got these 3 points where you actually get the token back in the callback. But only at these 2 points can you push to the device. Which is just awful. Who designed this? So this is a flow for an application that we recently built. You don't need to worry about most of the parts here. The point is we've got sign up, sign in, and this is the point where we log the user in. So this is how we manage push in a reliable way. So once the user's logged in, every time we launch the application, we call register device. We get our call back, and we do a put request over to our server, where we authorize the user, and then we look if the token exists. Now when we look if the token exists, we don't look under the scope of the user. We say, does it exist at all? Kind of treat it like a secret as such. And if the token does exist, then we'll come in here, we'll set the valid app time to be the current time. This way we've got visibility of when the token was last known to be valid. We set active to true, and I'll talk about why in a minute. And we'll set the user ID to be the authenticated user. And this way, when we sign up, we set the token to be active false. It means if I've got my device, I sign out of my account, and I sign my wife into the app on my phone, it means that it might give it the same push token as it previously did, but that will now be reassigned to her. And this prevents you kind of having issues where you're sending to the wrong user, sending to both users, or worst of all, not sending to any users. So what are valid tokens? I've already said tokens are valid when active as true, but we also have this invalid column in our database. And what that's for is that we don't waste bandwidth. We're already at a point where we're putting all the responsibility onto the phone for deciding whether it should show the push notifications or not. So we're at a point now where we're just trying to save ourselves some CPU cycles and some bandwidth. Now with iOS, you have to use the feedback service worker. So we call off to their service, we'll get a bunch of tokens, we'll loop through those, we'll set the invalidated at time to now. And that way we won't try and push them in the future. And then here, when we want to send a notification, we'll scope it to only the valid tokens. And Google, very handily, which is just awesome, there's just so much better about GCM than there is about APM. And I'm an iOS user, so you know what I'm saying about far to keep. When you send off to it, we'll immediately get a call back. We'll say, you tried to push to these devices, and we'll get back a sublist of those for any devices that are no longer reachable. And we can invalidate them at the time of pushing as well. Last thing that I want to talk about is payloads. So with the first version of each one of our applications, these are the payloads that we'd like to support from day one. It allows us to do things without having to know that we want to do them up front. So with a mobile device, you don't control the whole experience. You ask people to update, they don't have to update. Whereas a website, you're delivering that content down, you've got all the control. You can't do that on mobile. So we model our payloads like this. So you have kind of the normal stuff that you'd expect, like your alert, your badge, and your sound. But we implement a bunch of extra things that we want to support. So pop-ups. This is whether to show a pop-up whilst the person has the application open. And we have a title and a body text for that. And we also have what type it is. So it could be a show, a confirm, and an alert. So an alert is kind of a single button to close. A confirm is yes or no. And a show is forced on people. So if you have kind of a major security flaw, you throw a show alert up there just to force everybody to stop using the application. And we default on a lot of these properties, but the OK and cancel buttons, you know, you might have a context where OK and cancel aren't appropriate, so we'll send that down as well. We'll default to OK and cancel. And also navigate to view. So this is kind of used in conjunction with pop-ups. So if you show a confirm pop-up, for example, and you provide a view that you want to navigate to, then when you say OK on that confirm pop-up, we'll take you to it. The second thing is navigate to the view as a modal. So this is so that you don't interrupt the user's experience. If they're kind of on something, maybe they're ordering some products, you can kind of bring it up in front of what they're doing, and that way when they close it down, they return back to the same state, they've not lost their progress. And obviously just the parameters to send as well, so if you're maybe sending your order is ready, for example, you might want to send the order ID over at this one. Last things are a few resources. So this isn't push specific, but at SimpWeb, I spent a bit of time writing this guide, iOS development for teams. It's a way of managing your provisional profiles. It's kind of a structure for doing this reliably so that when people leave the company, you can still like maintain having connections through your push notifications or deploying apps easily. And yeah, so it's a good guide for kind of maintaining it so you're not always rejecting your certificates and kind of it's all a bit crazy sometimes. And some other useful links. So the APM troubleshoot guide, despite APM being a bit rubbish, they do encapsulate lots of stuff on one page. So credit to them for that. And a couple of links to those gems that I've used in my applications. And that is it. Thank you very much.